Hello students, today we are going to discuss the next part of this chapter, that is nothing but geometrical meaning of zeros of a polynomial. Already we have studied what exactly is a zero of a polynomial. Okay, we know that a real number which makes value of a polynomial 0 is called as zero of a polynomial, and we also have studied that the maximum number of zeros of a polynomial is equal to its degree. That is nothing but if we have a linear polynomial, it will have at most one zero. For quadratic polynomial, there will be at most two zeros. Okay, so a quadratic polynomial can have two zeros, it can have one zero, or it can have no real zeros. So these are the three conditions. Afterwards we will study this again in details. Okay, so in this way, if we have given a cubic polynomial, for a cubic polynomial there will be at most three zeros. Okay, now we are very well known with the concept of zeros of a polynomial. Okay, also first of all we have studied to find out value of a polynomial, and we know that if the value of a polynomial for some real number becomes 0, then that real number is considered as zero of a polynomial. Now we are going to see what exactly zero of a polynomial means geometrically. Okay, we'll see geometrical meaning of zeros of a polynomial. So how are we going to study this? Okay, suppose first of all, if we have given a linear equation or a linear polynomial or a quadratic polynomial, so we will draw the graph of those polynomials. Okay, and in that graphs we'll see what exactly zeros represent. Okay, so in order to do this, first of all we are going to study two different examples. We will take one example of linear polynomial and one example of quadratic polynomial. Through that we are going to study how exactly the zeros of a polynomial are represented geometrically. So let us start with our first example. Okay, we are going to study two examples. Already I have told you. So we are going to take first example of a linear polynomial. So let us take example p of x, that is polynomial in variable x, which is 2x plus 3. Okay, so it is a linear equation in one variable. Okay, as well as its degree is 1, that's why we call it as a linear equation. Now why I'm talking about degree, because we know that the maximum number of zeros of a polynomial is equal to its degree. Means this linear polynomial will have maximum one zero, which means there will be one and only one real number which will make value of this polynomial 0. Okay, so what are we going to do? Now we are going to draw the graph of this polynomial. So in order to draw the graph of this polynomial, the value of p of x we are going to consider as y. Okay, so 2x plus 3 is the given linear polynomial, and whatever values it is going to produce after putting the values for variable x, that values we are going to consider as y. Okay, so we can plot it on the xy plane or Cartesian plane. So let us draw the graph of y is equal to 2x plus 3. Now we know how to draw the graph. Last year also we have studied this in 9th standard. Okay, we put some values for x and we get some values for y after putting the values of x. For example, suppose if you put x is equal to 0, if you put x is equal to 0 in this equation, then we will get y equals to 3. Okay, so in this way we will find minimum two values, because we know the graph of a linear equation is nothing but a straight line, and to draw a straight line we will require minimum 2 points. Okay, so we have to find out 2 points, that is two ordered pairs. So let us do this. Okay, we have drawn this table. Suppose if you take x is equal to minus 2, so if we take x is equal to minus 2, then value of the polynomial will become minus 1. See, 2 into minus 2 we will get minus 4. Minus 4 plus 3 will give us minus 1. That is y is equal to minus 1. Actually minus 1 is the value of polynomial p of x is equal to 2x plus 3 at x is equal to minus 2. Similarly, let us take another value for x. Let us take plus 2. If we take x is equal to plus 2, then 2 into 2 will get 4. 4 plus 3, 7. So there we will get y equals to 7. So 7 is the value of polynomial p of x is equal to 2x plus 3 at x equals to 2. Okay, so we have got these 2 points. Now we know that 2 points are sufficient to represent a straight line. We can draw a line passing through two distinct points. So first of all, we will plot these points. First point we will take as -2, -1. Okay, we can plot that point on the xy plane. And second point we will take 2, 7. Okay, and the same point will be also plot on the xy plane or Cartesian plane. And after plotting the points, we will draw a line passing through these 2 points. Okay, so let us see how can we do it. This is the way. Okay, first of all we will draw the number lines, or we can say coordinate axis. After drawing the coordinate axis, first of all we will plot the point -2, -1, which is in the third quadrant. You can see it there. Then we will plot the another point, that is 2, 7, and we will draw a line passing through these 2 points. Okay, so we will get the graph of this equation as a straight line. Now this is the initial part which we were supposed to do. Now to understand the geometrical meaning of zeros of a polynomial, we are going to write some very important observations regarding this graph and the polynomial. Okay, so let us start one by one. We will write some observations. Our first observation, the graph of y is equal to 2x plus 3 cuts x axis exactly in one point. Okay, now if you, graph means straight line only, getting it? This straight line is cutting x axis or intersecting x axis in only one point, and that point is -3/2, 0. Okay, so this is the point. These are the coordinates of the point of the intersection of the straight line and x axis. Okay, so this is the first observation, that graph is cutting x axis in only one point. Second observation, the graph of y is equal to 2x plus 3 intersect x axis at point -3/2, 0. Okay, so this is the second observation. Graph is cutting x axis at one point and coordinates of that point are -3/2, 0. Now next one. Now see, we are going to focus on the x coordinate of the point of intersection of the graph and x axis. Now x coordinate of the point of intersection is -3/2. So what are we going to do? If we put x is equal to -3/2 in the given polynomial p of x is equal to 2x plus 3, then we will find that p of -3/2 is equal to 0. Which means if we put x is equal to -3/2 in p of x is equal to 2x plus 3, the value of the polynomial p of x at x is equal to -3/2 is 0. And we know that a real number which makes the value of the given polynomial 0, or a real number after putting the value or after replacing in the given polynomial, if the value of a polynomial becomes 0, then that particular real number is called as a 0 of the given polynomial. So here we can say that -3/2 is a 0 of polynomial p of x. Okay, now from this, okay, before proceeding further, we will write one more note. Now our given polynomial is a linear polynomial, and we know that a linear polynomial can have maximum 1 0. Why? Because the number of zeros of a polynomial is equal to its degree. Okay, so we know that the number of zeros of a polynomial is equal to its degree. Now the degree of a linear polynomial is 1. That's why it can have maximum 1 0. Now after combining these four notes or four observations, now we are going to write a very important note. Okay, so combining these four, what we can write? See, the graph is cutting x-axis only in one point and it has only 1 0. So one thing we can write here is the number of point of intersection of the graph with x-axis is equal to number of zeros of the given polynomial. Means graph is cutting x-axis at one point of y is equal to p of x. Okay, so if the polynomial having variable x is cutting x-axis in one point, means it has at most 1 0. Okay, if it is intersecting in 2 points, then it has maximum 2 zeros. Okay, and so on we can say. And second thing, what we see there, the graph is intersecting x-axis at point -3/2 comma 0. So x coordinate of this point is -3/2 and this -3/2 is nothing but 0 of the given polynomial. So one more thing we can write here is the x coordinate of the point of intersection of the graph and x-axis is a 0 of the given polynomial. Okay, so combining these two, we will write the next point, that is, thus the number of zeros and points of intersection of the graph with x-axis are equal. Means in the number of point in which the graph is intersecting x-axis is equal to number of zeros of that particular polynomial or polynomial representing that particular graph. And the second sentence, the x coordinate of the point of intersection is a 0 of the given polynomial. So whatever the point of intersection of graph and x-axis is there, okay, x coordinate of the point of intersection of the graph and x-axis is nothing but a 0 of the given polynomial. So these two are very important notes. Okay, so this is nothing but geometrical meaning of zeros. Means what we can say here, if a graph is cutting x-axis, okay, number of points the graph is cutting x-axis, that graph representing a particular polynomial has that many number of zeros. And second thing, okay, the 0 of a polynomial is nothing but x coordinate of the point of intersection of the graph with x-axis. So this is the geometrical meaning of 0 of a polynomial. To understand this properly, let us, before saying this as a property, going to see one more example where we are going to take a quadratic polynomial and we are just going to check whether all these properties are applicable to a quadratic polynomial or not. Okay, so let us take a quadratic polynomial. P of x is equal to x square minus 3x minus 4. So this is a quadratic polynomial. Once again, we are going to follow the similar procedure. So for that, we will draw the graph of this polynomial by considering that the value of p of x, whatever we get, that value we will consider as y. So we will say y is equal to p of x is equal to x square minus 3x minus 4. What does it mean? Means whatever values we are going to get for polynomial p of x, okay, those values we have considered as y, okay, because we want to draw the graph of this quadratic polynomial in Cartesian plane or xy plane made by x and y coordinates. Okay, so let us draw the graph of y is equal to x square minus 3x minus 4. Now this graph will be also drawn in the same way. Means we will consider some real values for x and we will find the resultant values of y. Again, by taking the ordered pairs of x and y, we will get a point and we will find number of points. Okay, now very important thing is this is not a linear equation or linear polynomial. We know that the graph of a linear equation or linear polynomial is a straight line, but that is applicable only for the linear polynomial or linear equation. Now this is quadratic equation. A graph of quadratic equation can be never a straight line. Getting this? So in order to draw the graph of the given polynomial, instead of finding only 2 points, we will require number of points. Okay, we will require at least 5, 6, 7, 8 points. Okay, from which we can get exact shape of this particular graph. Okay, of this polynomial. Okay, so we will take some negative numbers, we will take 0, we'll take some positive numbers. From that we will be able to find the proper shape of the graph representing the given polynomial. Now let us see. This is the table. If you put x is equal to -2 in the above polynomial, we'll get p of 2, which is nothing but y we have considered here. We'll get 6. Okay, if you put x is equal to -1, we'll get answer 0. If you put x is equal to 0, then we'll get y is equal to -4, and so on. We have found the respective values for the numbers 1, 2, 3, 4, and 5. Okay, so we have got this 8 ordered pairs, means 8 points. Okay, so we'll plot all these points on the graph, that is on the in the xy plane. Okay, -2 comma 6, -1 comma 0, 0 comma -4, 1 comma -6, 2 comma -6, 3 comma -4, 4 comma 0, and 5 comma 6. All these points we will be plotting on a graph. After plotting all these points on the graph, you will understand that it is not possible for us to draw a straight line which will pass through all these points simultaneously. So this is another proof that the graph of a quadratic polynomial is not a straight line. Then what does it represent? Let us see how we get the graph of a quadratic polynomial. Okay, so after plotting all these points in the xy plane, we'll get the points like this, and to join all these points we cannot draw a straight line which will pass through them, so we have to take the help of a curve. Now we have joined all these points in a sequence by using a curve. Okay, and we have got this shape. Okay, and this shape is called as a parabola. Okay, now this can be in the reverse shape also. Okay, if the coefficient of x square is negative. Okay, so we have got this shape. Now you will study more about this in the 11th standard, parabola and remaining conic sections also. But now we will just focus on our studies. Whatever the part important for us is there, we will just discuss these things. Okay, so we have plotted these points. After plotting the points, we have joined all the points by using freehand curve, and after joining them we have got a curve called as a parabola. Okay, so see, we are writing our observations. Our first observation: the graph of y is equal to x square minus 3x minus 4 is intersecting x axis exactly in 2 points. Okay, so once again we can say that whatever number of zeros of a polynomial are there, the graph is intersecting that particular x axis only in that number of times. Okay, so as it is a quadratic polynomial, we know that maximum number of zeros of a quadratic polynomial are 2, so it will have maximum 2 zeros. Okay, and graph is intersecting x-axis only in 2 points. Okay, so once again we can justify our statement. Okay, so number of zeros is equal to number of points of intersection of the graph with x-axis. This sentence is very important. Okay, remember this. Next one, the graph of y is equal to x square minus 3x minus 4 intersects x-axis at points 4 comma 0 and minus 1 comma 0. Okay, so it is intersecting in 2 points, and these 2 points are 4 comma 0 and minus 1 comma 0. See, I have highlighted 4 and minus 1. Why? Because they are x coordinates of the point of intersection of the graph with x-axis. Okay, let us see the next note. Now we know that the x coordinates of the point of intersection of the graph with x-axis are nothing but zeros of the given polynomial. Okay, let us check whether these 4 and minus 1 are the zeros of the given polynomial or not. So to decide that, what we will do, we will put x is equal to 4 and x is equal to minus 1 in the given polynomial. So if we put x is equal to 0, we will find x is equal to 4, then we will find p of 4 is coming 0, means 4 is a 0 of the given polynomial. Similarly, if we put x is equal to minus 1 in the given polynomial, once again we will find that p of minus 1 is equal to 0. So for the real numbers 4 as well as minus 1, we find that the values of the given polynomial p of x is equal to x square minus 3x minus 4 are being 0. So we can say that 4 and minus 1 are zeros of the given polynomial p of x. Okay, so once again we can say that the x coordinates of the point of intersection of the graph and x-axis are zeros of the given polynomial. Okay, next note is again quite similar. We know that a quadratic polynomial can have at most two zeros. Okay, a quadratic polynomial can have maximum two zeros. That's why it is intersecting x-axis in 2 points. Okay, so once again we are going to write the fifth point, whatever we have studied for the linear polynomial. So now we will be sure that the number of zeros of a polynomial is equal to the number of points in which the graph of the given polynomial is intersecting the x-axis. And the second very important point is the x coordinates of the point of intersections of the graph x-axis are nothing but zeros of the given polynomial. So once again let us write this sentence. Thus the number of zeros and the point of intersection of the graph y is equal to p of x with x-axis are equal. Okay, so number of zeros equal to number of point of intersection of the graph with x-axis. And the second note, the x coordinate of point of intersection is a zero of the given polynomial. Okay, once again we can see that wherever the graph is intersecting x-axis, x coordinates of those points are nothing but zeros of the given polynomial. Once again we have observed the same things. Okay, so this is nothing but geometrical meaning of zero. So geometrically, zero of a polynomial is nothing but x coordinate of the point of intersection of the graph representing the given polynomial and x-axis. Okay, and the graph of the given polynomial intersects the x-axis into that number of points which equals to number of zeros of the given polynomials. Okay, so this is the very simple thing to understand, but all these things are applicable only for polynomials with variable x. Suppose we have given a polynomial x is equal to p of y, then all these things will be true, but vice versa. Okay, similarly, suppose if you are given a polynomial in variable y, p of y, so there we are going to consider the number of point of intersection of the graph with y, and in that case y coordinate will represent 0 of that polynomial p of y. Okay, remember this. Let us see some more examples. Now the question is, find the number of zeros of the following graphs of y is equal to p of x. Okay, we have given the 6 graphs there. Okay, so here the first one, we have given the graph of y is equal to p of x. It means variable of the polynomial is x. So we will consider number of point of intersection with x-axis only. Instead of this, suppose if we have given the graph as x is equal to p of y, means if y is the variable of the polynomial, then in that case number of point of intersection with y-axis will be considered. Okay, so let us discuss the answers of this one. It's very easy to do. The first question, clearly we can see that the graph is intersecting x-axis only in one point, so it has at most 1 0. Okay, and remember that the graph representing this particular polynomial is not a linear polynomial. Getting it? Because linear polynomial we can say if and only if it is a straight line. Getting it? So it may be a cubic polynomial because it is something like s-shape. Okay, so see here, we are not at all going to consider the point of intersection of the graph with y-axis. That is another thing which you have to remember. Okay, if we have given polynomial p of x, to find out number of zeros from graph, we will just consider the point of intersection of the given graph with x-axis only. So answer of first one, we'll write as graph of y is equal to p of x intersects x-axis in one point, it has at most 1 0. The second one, this we can definitely say it is a graph of a quadratic polynomial. Okay, because it is parabolic shape and it is intersecting x-axis in 2 points, so it has at most 2 zeros. Okay, and we can say that it is the graph of a quadratic polynomial. So second one, as graph is intersecting x-axis in 2 points, it has at most 2 zeros. The third one, you can see in third figure, the graph is intersecting x-axis in three distinct points. So it has at most three zeros. Okay, this is the graph of a cubic polynomial. Okay, which is almost in ulta S shape. Okay, so third one, as the graph of y is equal to p of x intersects x-axis in 3 points, it has at most three zeros. Fourth one, it is a graph of a linear equation, linear polynomial clearly, and it is intersecting x-axis only in 1 point. So we can say that it has at most one zero. Next one, it is a graph of a quadratic polynomial. See, now this example is very important. We know that the shape of parabola represents a quadratic polynomial, but here it is touching x-axis only in 1 point. Okay, why is it so? Because in this case, the case is like both the zeros are equal. So this is a quadratic polynomial having two equal zeros. Getting this? This is the quadratic polynomial having two equal zeros, and geometrically we cannot say show same point at two different places. That is the thing. Okay, so that's why this is the graph of a quadratic polynomial only, but it has only one zero, because the graph of this polynomial is intersecting x-axis only in 1 point. So it has at most one zero. As it has two zeros, but both the zeros are equal, both the numbers are same, so mathematically it is one number only, one zero only. Okay, next one, sixth, we can see that this graph is intersecting x-axis in 1, 2, 3, 4 points, so it has at most four zeros. Okay, so these are all answers of these questions. Once again, we are going to see a note here. Okay, the note is what I told. Instead of suppose y is equal to p of x, if we have given a polynomial x is equal to p of y, in that case this polynomial is nothing but a polynomial having variable y. See, thus the number of zeros of a graph x is equal to p of y is the number of point of intersection of the graph with y axis. Okay, why? Because this is polynomial in variable y. So we have to consider the number of point of intersection of the graph with y axis to determine the number of zeros. Okay, if it is a polynomial in variable y. So this you have to read very carefully, and in that case y coordinate of the point of intersection is nothing but 0 of the given polynomial. Okay, so this you have to remember very carefully. Okay, this note is very important. Okay, so if it is, suppose in the given question, suppose we are discussing question number second. Okay, and suppose second question is given to us as it is the graph of something x is equal to p of y. Okay, so if it is graph of x is equal to p of y, then the number of zeros will be only one, because the point of intersection of the graph with y axis is only one. That's why we will have only one zero if it is graph of x is equal to p of y. Okay, so this you have to understand carefully, and to write zeros also we are going to consider the y coordinates. Okay, let us now discuss the second question. The second question is also to find out number of zeros of the given graph, and we have to also write what are the zeros. But see here, we have given the graph of y is equal to p of x, means variable of this graph, this polynomial is x. Okay, so this is the graph given to us. Okay, first of all they have asked us to write the number of zeros. Clearly we can see that the graph is intersecting x-axis in exactly 3 points, so it has at most three zeros. Okay, now they have asked us to write what are the zeros. Okay, variable was x, that's why we considered the x-axis. Okay, now they have asked us what are the zeros. Now to write what are the zeros, what we do, we know that the zeros of a graph y is equal to p of x is x coordinate of the point of intersection of the graph with the x-axis. Now what do you see? First of all, just see the coordinates of the point of intersection of the graph with x-axis. First point we can see it is -2, 0. Second point is origin itself, whose coordinates are 0, 0 and third point is 2, 0. So we have the graph of y is equal to p of x intersects x-axis in points -2, 0, origin that is 0, 0 and 2, 0. So now zeros are nothing but x coordinates of these points. So that is nothing but -2, 0 and 2. So these are the zeros of the given polynomial. Okay, so in this way, if they are asking us to write the zeros and if they are providing us the coordinates, we just have to write the x coordinate if the graph is p of x. Okay, the polynomial is p of x. If it is p of y, we will consider the number of point of intersection with the y-axis to write the number of zeros, and to write what are the zeros, we will write y coordinates of those points. Okay, you do these questions for homework. I have given some questions. These are very simple questions. You can find it in your textbook also, to write the number of zeros. You can easily do it. Okay, so this is nothing but all about the geometrical meaning of zeros of a polynomial. Okay, so geometrically, zeros of a polynomial nothing but x coordinate of the point of intersection of the graph with x axis if the given polynomial is p of x. Okay, so do these questions. You may find some more interesting questions in this. All the best. Complete the homework.